Okay, so we're going to talk about some anti-patterns for integration, or as I like to think of it, the 7 deadly sins of integration. So we're going to look at 7 different anti-patterns. So let's start off with the first of those, which is the integration that talked too much. So we want to sync up the records in a file or large data set with an external system. So for example, we might be uploading employee records into HCM, or synchronizing journal transactions, or putting orders in from a website into an order management system and a warehousing system. And one way that we could do this, which sort of seems natural as a procedural programmer, is that we just use an invoke activity within a looping construct, within a for loop or a while loop, to call external APIs for every record. This causes us some problems because now we're making lots of calls to the downstream system. So that puts the downstream system under pressure. Also, it's possible that the downstream system has a usage-based pricing model. For example, Salesforce has a limit on the number of calls you can make. And so if you put it in a tight loop, you could find yourself incurring additional charges from your SaaS provider. Basically, bad idea to put them in one record at a time in a loop, because we put load on the back-end system and we may incur transaction charges. So what's the best practice here? Most applications have the ability to accept multiple records in a single request. So if that's the case, for example, Salesforce has a limit of 200 records through its bulk API. The Oracle Fusion apps have 100 records as their limit. Right now, Oracle Service Cloud, has 1,000 records. So instead of making 200 calls to Salesforce, we could make one call with 200 records. Less load on Salesforce, will be faster because we're making one call and Salesforce has all 200 records to process at once. And we're only making one call so that we're not going to run foul of transaction quantity limits. And most of the adapters have that ability to send large data, not just as multiple records in a single request, but also as attachments or files. So in the first use case, it's, hey, I can put more than one record in a standard payload. In the second case is, hey, we actually send the data in a file or as an attachment. And in this case, the numbers go up dramatically. So in Salesforce, it goes from 200 records to 10,000 or up to 10 megabyte files. In ERP Adapter, we can support FBDI files that are megabytes in size, so very large files. If we're going to do that, we use the stage file action to append to the file. So we might be building up the file across multiple calls in a loop. We use the stage file append to add that to the file, and then at the end, we have the file ready to go. So that's the best practice. So here's an example of that. So what we do is we retrieve a file from a source. This could be any one of many different sources. It could be a CX application. It could be another ERP system, and we need to load it into ERP Cloud. So first of all, we have a scheduled flow where we poll for the new file. We retrieve that file. We do any enrichment, transformation, and then potentially in a loop, we appending that data into a stage file, and then we initiate the import into Fusion ERP. As part of that import, and this is one of the benefits we probably talked about yesterday, that we're able to upload, initiate the flow, and register for the callback all in a single activity in OIC. Then when the flow completes, we can get the status back. So that's a good example of using the bulk APIs to reduce the load on the target system and also on OIC. So avoiding that chattiness. So let's look at the next one, which is the scheduled job which never gave up. All right, so the use case here is that the process records within set of files with a tight SLA. So for example, we might need to synchronize employee records into Active Directory from HCM, or generate a benefits file and send it. So we want to do this on a schedule. It has to be done at end of day typically, and then we need to run it, and then we need to get it out in a fairly short time. So one approach is to look for all the files to process and then loop over each of those files to sequentially process it until there's no files left to process. The problem with this is, if you remember, we have a limit on the number of scheduled jobs that we can run. So if there's a lot of files, this integration is going to run for a long time. So we're not going to be able to run other scheduled jobs, or we're going to have a reduced capacity for those scheduled jobs. Effectively, we're starving other jobs, which is always a mean thing to do. The other thing is that the processing gets pinned to a single resource within OIC. So we have multiple resources in an OIC instance, but if you just try and do all the work in a single integration in a single loop, they will all execute on that same resource. So what's the solution to avoid this? So first of all, we can limit the number of files that we want to run in a scheduled run. So we can run the schedule more frequently, perhaps, use the schedule parameters to remember the last processed file, and so that we can then resume processing next time we run. We can invoke a run now from the same integration to trigger the processing of the next file if waiting for the next schedule run is not feasible. We can also, and it's not mentioned here, is potentially kick off an async integration to actually process the file. And then if we have multiple async integrations running, those can run in parallel. However, if we do that, we should limit the concurrency of doing that, and we would still want to combine it with limiting the number of files that we processed in one run. So this avoids us locking up the system on a single integration. It gives us the ability to do some form of parallel processing by spreading the load across additional nodes in the OIC environment. And so an example of where we've seen this is where we've been sending benefits enrollment to a provider. So in this case, we're generating extract files in HCM, and we might get multiple of those files. We retrieve them from within OIC, decrypt them, generate the benefits file, compress and encrypt that, and then we write that out to the benefits provider. Now, this works great if there's only one file or a small number. If there's a large number, then we end up looping, and this can take a long time. So we may want to make this run in parallel by using async, or we might want to defer the scheduling by doing a run now, or limiting the number of files we read at a time. Okay, now there's a particularly egregious problem here. So this is our third anti-pattern. Is, look, I hacked my integration. Hard though it is for you to believe, it is not possible to do everything in the OIC mapper. There are certain constructs that you might use that are not supported. For example, I'm a big fan of templates and pattern matching for indeterminate depth schemas. Not supported in the OIC mapper. What do? Well, no problem. We export the IAR file, we open it up, we find the XSL file inside it, we edit that XSL file, and then zip it all back up and import it back into OIC. This can lead to problems. We keep a certain amount of metadata in those files, and it can lead to validation failures. It can also lead to activation failures because we don't verify that the XSL is actually valid, because that's done in the editor, not at activation time. So there's a number of things. Also, we might accidentally touch something else in the file. And then when we zip it up, that contamination also carries through. So there's a lot of ways that this can go wrong. There are a few legitimate use cases where the IAR file needs to be edited. In that case, the support organization will have a signing tool that they'll be able to regenerate a signature for an IAR file. So don't do it because you can screw up the metadata. Don't do it because you might not activate, and don't do it because we're going to stop it in the future. There is an import map feature in OIC. You can keep that metadata consistent because you're never editing anything outside except for the XSL file. When we import the XSL file, we validate it. We validate it against our XSL engine to make sure that we can actually execute it. In addition, we can then we also allow you to look at the source code for that. How do you get the XSL in the first place? There is now a source code window in the mapper. You go to the source code window, you do Control-A or Command-A to select everything in there, and then Control-C or Command-C to copy it. And now you can edit it in your favorite XSLT editor. For me, that is VI. But some people might use XML Spy. Somebody else might want to use JDeveloper. You're free to use whatever you like. Then you can, once you've made your changes, import it back in. Now, we would appreciate you that there's a link here that takes you to Oracle Cloud Connect, where you can put suggestions in. If you need to do some manual editing of an XSL file, please tell us why, so that we can consider adding that feature into the mapper in the future. Okay, so the next one is the synchronous flow, which tried to do too much. We have an integration that triggers very complex processing with enrichment and updates across multiple systems. And this has a number of different challenges associated with it. So first of all, you end up with huge flows with large numbers of invokes and conditional logic, which is very, very difficult to understand and to follow. Now, you can help a little bit by using scopes to elide some of the complexity, but it's still very hard to follow these. Also, we sometimes see people doing this in synchronous flows with invokes within a loop with large numbers of iterations, which again is another anti-pattern that's in there. So multiple anti-patterns here, potentially, if we're trying to do too much in our synchronous flow. And the challenge is that a synchronous flow is a blocking call. It holds resources and starves other integrations. So there's a limit on the concurrency. And secondly, we're susceptible to any timeouts. So for example, if we're invoking a target system 20 times, and today it's 50% slower than yesterday, that adds up across each of those 20 calls, and we now have a significantly slower response, and that we may trigger a timeout. Remember, I said that the timeouts are 5 minutes, so that if we take longer than that, the caller will never get the response. I really, really, really need to do this, though, so how can I do it in a way that isn't an anti-pattern? So this is actually a real customer integration. And if you look carefully, this isn't all of it. There's more off the bottom of the screen that we're not showing. We have customers that have integrations with hundreds of steps within them. Multiple loops, multiple conditionals. So how do we improve it? Well, first of all, as we talked about this morning, we can look at fire and forget flows, asynchronous flows. So the integration platform, as I said, would send a 202 accepted message back to the client. The client says, great, I know that's going to arrive eventually. And then we guarantee processing and support resubmission of failures. So that's what we talked about with those async patterns this morning. So we could use that. We could, if it really has a synchronous requirement where we need to send a response back, such as, for example, we're creating an order and we need to get the order ID back and put it into the calling system, then we should look at splitting the integration into the mandatory part that needs to retrieve data to be sent back, and then trigger the rest of it in an async fire and forget flow, so that we basically have now two flows: a small sync flow that gets the data needed to be sent back to the caller, and then an async flow which does all the additional processing. In addition, if we're making lots of calls, we should see if it's possible to replace that with a more coarse-grained API that we can call. For example, this goes back to the earlier AntiPattern of trying to send data as single calls instead of blocking it up. So in this case, we might want to also look as to whether we could apply the solutions of that AntiPattern to collect chunks of data and then send it in larger groups of perhaps 20 or 100 records at a time rather than a single record. So that's the trying to do too much in a sync flow. Now let's talk about too many keys for the same door. So in this scenario, we have a problem with our developers. Well, we always have problems with our developers, but that's another matter. But in this case, it's often the case that the developer is told, create this integration. So they'll define their own connection. And to see this problem, you only have to look at the OIC Product Manager's Sandbox application instance. I think we have something like 800 connections in there. And a lot of them are duplicates pointing to the same application. And because everybody names their connection how they like, we might have 2, 3, 4, 5 or more connections all going to the same app. So this is an anti-pattern because now we're potentially using different sets of configuration and credentials for each connection to the same application. So that's inconsistent and might lead to confusion in the future. Not mentioned here, but the operations team will not like you if you have lots and lots of connections for them to configure as they move into their test and production environments. So we want to have as few connections as we need and no more. And so it's a real pain to manage, particularly if we have to update endpoint credentials or configuration because we have to go into multiple connections. It also makes it hard to do an analysis. Within OIC, we have an analysis that you can find out which integrations are being used by a connection and which connections are being used by an integration. That kind of analysis becomes meaningless if every integration has its own connection to the same application. So it makes it harder for us to figure out what the impact is of changing an application, upgrading it, or perhaps changing permissions on something. We have a function within OIC called the configurator. So we can use the configurator to edit or replace connections in an integration. The restriction is that the new connection must be of the same type as the old one. And so here we can see a couple of connections. If we wanted to, we could go into the replace with existing, which would give us a drop down and show us the available connections that we could replace it with. And ideally, we'd choose the same connection for all our REST endpoints that were needed. At that point, we've reduced the number of connections we have to worry about. Another thing that we can do is have a custodian or librarian who's responsible for creating the needed connections and make sure duplicate connections of the same type aren't created. Related to this is having a best practice for naming conventions around connections. So that I've seen one example that I've seen is where they name the connection based on the source system and the target system. So they name the connection based on the source system and whether it's prod, dev, or test. Although that's a bad way of doing it. Don't ever name things with prod, dev, and test. Let's look at another example of an anti-pattern. I read more than what I could chew. So we want to read a file with a large number of records and then process the individual records. So that's easy. We read the whole file using the read file operation. And then we have a for loop where we go through each individual record. The problem with this is that we're now consuming a lot of memory, even though we're only processing a record at a time. This is not smart because this memory is being shared with other integrations in our instance. And so it could impact those, leading to slower performance if under the covers we're having to do memory cleanup, or in the worst case, leading to out of memory errors. Also, it doesn't take advantage of our, it's not quite a map reduce, but I know we like to refer to it as that, but the ability to chunk items within and do parallel execution. And again, it doesn't allow us to do that very easily. So what's the best practice? Is that we retrieve the file, and that gives us a file handle, which we can then use to read that file with segments. So we download the file to a stage location. The stage files are secured and are deleted at the end of the instance. So when an integration instance completes, any stage files that were being used are also deleted. We can then use the read file with segments or the chunked read capability. If we need to, we can, so that will then effectively appears as a for loop within OIC. So when we do read segments, it automatically builds the for loop for us. If we want to process individual records, we can build another for loop inside that. But now we're only bringing into memory the chunk size, which is normally 200 records. So we're bringing in just portions of the file into memory, and then we can either process those as a chunk if there's a bulk API that we can use or a multi-record API that we can call. If there isn't such an API, then we can always have another for loop inside that iterates over the individual records in the chunk. We also will do processing of these segments in parallel. And so we get advantage of parallel processing as well within, so each item, there might be multiple runs through the for loop happening concurrently. So much better way of doing it. We get parallel processing, so it probably executes faster. It puts less load on the system because we're not materializing the whole file in memory in one go. And also it allows us, makes it easier because we've already chunked the data to take advantage of block APIs, multi-record APIs in target systems. I skipped the spring cleaning. When we're developing, we have a nasty habit of saying, oh, well, I think I can improve that, but I want to leave the old one lying around. So I'm going to create a new version. Great, OIC makes it really easy to do that. And it's actually faster to create a new version than it is to deactivate and start editing the old one. So there's multiple reasons why you might end up with multiple versions of the same integration. In addition, in production environments, we sometimes have schedules that we set up that continue to run even though the business requirements have changed and that job actually isn't needed anymore. Typically, we are terrible hoarders. Integration flows, scheduled jobs, lookup tables, once they're created, we never check if we still need them. We just keep adding to more. We see a proliferation of integrations, of connections, which relates to the too many keys anti-pattern. We see too many schedules, we need to go back and look at them. Which jobs perhaps aren't needed anymore because we've replaced that. So I have seen customers picking up files from a file location and importing into an HCM system after they've turned off the originating system, but the files are still there and they're being picked up every night and worked on. We often see multiple flows doing very similar things. And people haven't actually refactored and said, well, actually, these are really the same integration. Let's just have one of them and deactivate the others. And then most common is lots of dead integration flows. It can be hard to find the integration you want. One thing we've done to make this easier is we've improved the filtering. So you can now filter on who created, on the creator or editor of an integration or a connection. We've also added metrics into the OIC monitoring screens so that you can monitor how many integrations you actually have, how many of them are active, and how many are not, so that you can reduce the size of your listings by getting rid of unneeded integrations. So there's a number of tools we've put into the product to help you with this. Best practices here is analysis of those existing flows. So look at the monitoring data for historic runs. It might be that the flow is running but never picks up any data because the application it picked it up from is decommissioned. Look at flows that are both subscribing to the same event and consider either combining them or doing a publish-subscribe pattern if they really need to be kept separate. Get rid of flows that you don't need. If you've got flows that can get by, use lower frequency to reduce the load on the system. Delete schedules that aren't needed. Basically, clean up your mess. So that brings us to the end. So we've talked about chatty integrations, making too many calls to other systems where we want to should be using multi-record interfaces. We talked about scheduled jobs which run forever and steal resources from other schedules, and how we might want to put a limit on how many records or files they process and then reschedule them again, either with a schedule now or kicking them off to async flows that could execute in parallel. We looked at the heinous crime of cracking open your IAR file and editing the XSL inside, but all kinds of nasty problems that are really gnarly and difficult to troubleshoot come because of this, because nobody wants to admit that they cracked open the IAR and that they might have broken something. The synchronous flow, which tried to do too much, these hundreds of activities or large counts on loops, but it still leaves you to fix the problem and try not to do too much in sync flows. Move them to async, break them apart, use bulk APIs, going back to the chattiness issue. The too many keys for the door problem. This is where everybody creates a connection to the same application. Get somebody to monitor the connections or be the sole person who creates them so that you have some management of them. Have a naming scheme so it's easy to see if there's an existing connection you can reuse. And use the configurator so that you can replace the connection in an integration with a single connection for all the integrations. The read more than what I could chew. Don't read a big file into memory in one go. Do chunked reading, and then you can take advantage of parallel processing, and you can take advantage of splitting the work so that you're not stealing memory from other people. And finally, try and keep your OIC instances clean. Delete unneeded connections, lookups, integrations. Make sure that your schedules in production are really doing meaningful work and are not trying to pick up data from an application that is no longer there. So that is the 7 deadly sins of integration.